So in this exercise, we're given a simple circuit that involves two batteries and two resistors. And we're asked to perform a couple of things on this circuit. First, we note that we do have values assigned. So R1 is 8,200 ohms, R2, 1,800 ohms. First voltage source is 12 volts. Second voltage source is 2 volts. So we have everything defined. So now we want to look at part A. So part A, they're asking for the total resistance at the terminals A, B. So that's these terminals here. So to do that, we need to think of this as removing the voltage source here and just looking at the circuit on the right side of A and B. So that's looking into here. And they're asking what that resistance is. So that's resistance RAB. So part A, when we look at that, we should short out all voltage sources and open circuit all current sources. So there are no current sources, but we do have one voltage source right here. So it'd be like we took a wire and shorted this out, which in a sense would be like removing this here, and this is what's left for the circuit to determine the resistance. So when we look at that, what we have then is RAB is simply R1 plus R2 because they're in series with each other. And so when we plug in values for that, we've got 8,200 ohms plus 1,800 ohms. And when we add those together, that's 10,000 ohms, or we would probably more readily call that 10 kilo ohms, dividing by 1,000. So this is the answer to part one. So again, looking in to the terminals A and B, if we were to put an ohm meter on there, that's what we should register on the ohm meter is 10 kilo ohms. Okay, so now for part B, when we look at part B, they're asking us to calculate the current. So that's this current here, current I. And this basically boils down to just an Ohm's law application. So for part B, remember that V is equal to IR. But in this case, we are solving for I. So then I is going to be equal to V over R, as we divide both sides by the resistance. Now we have to keep in mind that this is going to be the total voltage around our circuit divided by the total resistance in our circuit. So in this case, as we go around the loop, adding these up, our total voltage will be V1 plus V2, and our total resistance will be R1 plus R2. So that takes into account everything that's in the circuit. So when we plug those values in, we'll have 8,200 plus 1,800. That's all divided by 12. Oh, excuse me, I've got this upside down. So it'll be our voltage is on top. So that will be 12 volts plus 2 volts. And then on the bottom, we'll have 8,200 plus 1,800. And so when we calculate that out, that's going to be 14 over 10,000. And when we calculate that out, we get 0.0014 amps. But we would readily more say, by moving the decimal 3 places to the right, that would be 1.4 milliamps. So this is the answer to part B. So the resistance looking in is 10 kilo ohms. The current that flows through the circuit is 1.4 milliamps. So now we're going to go to part C. So part C, they've asked us to determine what the voltage is across this resistor, but they want us to do it using voltage division. So we'll recall for part C, voltage division. So that'll be the voltage across our load resistor is equal to our load resistor divided by the load resistor plus the other resistance in the circuit, and that's going to be times our V source. So in this case, our RL is R2, so it'll be R2 over R2. The remainder resistance is R1. And then our voltage, source voltage, is our two voltage sources, V1 plus V2. So again, as we plug these values in, we will get 1800, because that's the value of R2 right there. And that's going to be divided by 1800 plus 8200. Again, the total resistance in the circuit. And then that's going to be times 12 volts plus 2 volts. So we bring that down here, and we start to add this up. So that'll be 1800 over 10,000 times 14. And when we put this in a calculator and calculate it out, we should come up with 2.52 volts. So this is the voltage. If we were to take a meter and put it across R2 when this circuit is connected, we should measure a voltage across that resistor of 2.52 volts.